All right, Peter ate 7/4 of a pizza. Is this possible? Is it possible, class?
No.
How many of you feel like it is? Quiet hands now. How many of you feel like it is possible? How many of you feel like it is not possible? Okay, so if you're feeling like it's not possible, okay, yes, it is possible. So we're going to draw a model of what that looks like. So we have, here's a pizza. What size are the parts of pizza?
7.
What is the size of the piece? The pieces here. What are the sizes, Ronnie? Well, this is a whole, but what size is are the pieces of the pizza? It's up here. It tells us up here. Daniel.
4.
They're fourths sizes. So I'm going to split this into fourths. Okay? I need everybody paying attention. So I'm going to, how many pieces of pizza does he have? Raise your hand, please. Horace.
1.
No, how many pieces up here? Looking at the fraction up there. How many pieces of pizza does he have?
7.
He has 7. Okay, so I'm going to start shading him. 1, 2, 3, 4. Wait, I didn't get to 7. Am I in trouble now? I said yes, this was possible, and all of a sudden it doesn't look possible. What do I need to do still? Preston.
You need to make another model and continue shading.
Okay, so I'm going to make another pizza.
Yeah.
And what do I do with it now?
You should have 3 more.
3 more. It's only 1 right now.
Oh, you divide it into 4 pieces.
And why am I dividing it into 4 pieces, class?
Because 4 is the denominator.
Right, 4 is the denominator. It tells us that that's the size of the parts. Okay? And now I can continue. I've shaded 4 here. Now I'm going to shade 5, 6, 7. Now going back to my question up here, Peter ate 7/4 of a pizza. Is this possible? Is it possible?
Yes.
Yes, it is. They must be size small pizzas, right? I'm thinking personal size pizzas because most people can't eat almost 2 whole pizzas. Correct. All right, and then write it as a mixed number. Nicholas? 1 and 3/4. The 1 represents what kind of a number?
A whole.
Whole number. The 3/4 represents what kind of a number?
Adding
Fractions.
fractions and
Okay? And we got this from here's the whole pizza, and here's the pizza that is a fraction of a pizza. It's not a whole pizza, it's a fraction. So we have a whole number and a fraction, and that's why it's a mixed number, because it's mixed with whole numbers and fractions. Okay? All right, go ahead. We're going to continue on 7-6. We're going to start over on the very first page, so go ahead and turn to that page. Mr. Fox has 2 3/6 loaf of cornbread. Each loaf was cut into 1/6 size pieces. If he has 14 people over for dinner, is there enough bread for each person to have 1 piece? The question over here was, what is the size of 1 piece of bread relative to the whole? And what did we decide yesterday? 1/6. We got that information from right here that they were 1/6 size pieces. How much bread does Mr. Fox need for 14 people? We decided that we needed 1 piece per person, and so that was a total of 14 pieces. This we did yesterday. We talked about what a mixed number was. A mixed number is a number represented by a whole number and a fraction. We just did one on the board. You can write a mixed number as a fraction. So we started, our fraction up on the board was started by 7/4, remember? And then we wrote it as 1 3/4. So mixed numbers can be changed to fractions, and fractions can be changed to mixed numbers. Okay? We just did one on the board. Then we modeled yesterday what that would look like. 1 whole plus 1 whole, that gives us the 2 whole right here. And then 3 6th size pieces. Okay, so we said it's 1 whole plus 1 whole plus 3/6. And then we did step 2. We did this with our fraction pieces, and we changed the 1 whole to 6, and there was 6/6. Is this coming back to you?
Yeah.
And then we brought down the 3/6 that we had over there. Because we can add, since they have a common denominator, we can add the numerator. We get 6 plus 6 plus 3, and what does that equal, class?
15.
15. All right, and the denominator was 6. So if we changed this mixed number to a fraction, it would look like 15/6. Okay, are we done with this problem?
No.
No, we're not, because we need to go back up and check out what the question was. The question was, can we see it? Let's see. Is there enough bread for each person to have 1 piece? How many pieces of bread did we need? 14. Can we tell by our answer if we have enough 1/6 size pieces? Raise your hand when you can explain to me whether or not we have enough and how you can tell. Okay, Penny, what do you think?
We have enough because there's over 14.
How many are there? Right. So he says we have enough because there are 15 6 size pieces, and we need only 14. So there are enough. If you're not seeing this, go back and look at the model up here. Okay, remember these bottom is the total, this is the bottom 6 are here, down here are the total number of 6 size pieces, and we can just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 slices of bread. We're imagining that we've sliced these loaves of bread up here into 6. Right, to weave a bracelet, Charlene needs 7 pieces of brown thread. Each piece of thread must be 1/3 of a yard long. How much thread should she buy to weave the bracelet? So she needs 7 1/3 size pieces. 7 1/3 size pieces. Okay, so you can model it. Here's 1, here's 2, here's 3, 4, 5, 6, 7 pieces. You can write your pieces right here. 1, 2, 3, 4, 5, 6, 7. They show it against the number line. You can also do 1/3 plus 1/3, because this is the size of the pieces, right? We need 7 of them. Should she go to the fabric store and have the lady cut 1/3 size pieces for her?
No.
Then let me tell you that the lady at the fabric store or the man at the fabric store is not going to be happy about cutting individual 1/3 size pieces. You need to buy the total that you need, and then you need to go home and cut it into 1/3 size of a yard size pieces. Okay, so we need how many total?
7.
Okay, is Aaron the only one paying attention? How many total pieces?
7.
I used unit fractions here. They look like they're unit fractions. 1, 2, 3, 4, 5, 6, 7 of them. If I add them, they all have a common denominator. So if I add the numerators, what do I get? 7, which we've already decided here we were going to model. We did it, and now I worked backwards, and there it is, 7/3. Okay? Now we're going to find how many holes there are in 7/3. And we don't mean holes like hole in the ground. We mean hole like a whole pizza. And how many thirds are left over. So you need to think, how many pieces make a whole if we are working with third size pieces? How many of those do we need to make a whole? Raise your hand if you can tell me. how many third-sized pieces, think of a pizza that's divided into thirds, how many pieces do we need to make that a whole pizza or a whole something? What do you think, Sophia?
3.
We need 3 of them, right? Because if here's our pizza, and we have our peace sign, in order to have those third-sized pieces equal whole, we need 1, 2, 3. And we know that from the denominator. It tells us the third-sized pieces, so I need 3 of them to make a whole. I also know that 3/3 makes a whole, don't I?
Yeah.
Okay, so I'm going to take my model, and I'm going to take 1, 2, 3, and I'm going to call that 1 whole or 3/3. They're the same. That's a very ugly 3/3. Okay, then I'm going to take 1, 2, 3 again, and I'm going to make another 3/3 or 1 whole. Can I make another 1 whole, class?
No.
No, I cannot. So 7/3 equaled 1 whole here, 1 whole here, and what was my fraction of leftover? 1/3. So if I put that all together, 1 whole plus 1 whole plus 1/3, raise your hand if you think you know what that's going to look like as a mixed number. 1 whole plus 1 whole plus 1/3. What do you think, Malia? 2 and 1/3. 2 whole and 1/3. Very good. So Charlene, when she goes, she should buy 2 and 1/3 yards of thread. And then she has enough. Let's see what this would look like on a number line. We're going to compare mixed numbers to what their fraction would look like. So if we had 1 whole, remember last week I talked about how a number line doesn't necessarily have to go 0 to 1.
Yeah.
If it depends on what you want to work with, you can just use those numbers. So this number line goes from 1 to 3. 1 whole to 3 whole. Okay? And so in this case, we have 1 whole equals 6/6. We're working with a fraction of what size pieces, class?
What size pieces?
No. What size pieces are we working with right here? 6. Very good. So if we have 1 and 1/6, so 1 whole, I want you guys listening and looking up here. If we have 1 whole and it equals 6/6, and then we add 1 more 6 to that, how many 6 do we have now? 7/6. Okay, we had 6/6 and we're adding 1 more, so now we have 7/6. If we have 8/6, we know that's a whole. How many are left over for my fraction? How many? Who said 2? Owen is right. We have 2 left over because we used 6 to make the whole, and we have 2 left over, and that's 2/6. Okay, now I have 1 and 3/6. Don't write. I just want you to follow me. I'll let you copy it in a minute. Thank you. Thank you, Emil. If I have 1 and 3/6, so 1 equals how much?
6.
And now I have 3 more 6. How many 6 do I have now? I add 6, and I'm adding 3 more. That's 9/6. If I have 10/6 and I want to change that to a mixed number, if I take out a whole, how many am I taking out? How many pieces would make this a whole?
Oh.
Sean?
12.
No, that would be 2 wholes. Preston?
6.
6 of these, 10 right here, 6 of those is going to give me a whole. And then how many are left over? 4. Okay, what if I have 13/6? How many, I want you guys to really think about this. 13/6, how many wholes am I going to get out of 13? There's 6 size pieces. So if I was separating that, how many whole numbers am I going to get And how many are going to be left over? Raise your hand when you know. How many holes? 2 holes. Where am I? Oh, it tells you right above it. 2 holes. And then I have 1 left over. Because 2 holes will be 12/6. Because 12/6 just means 6/6 plus 6/6. So I can pull 1 hole plus 1 hole, which is 2 hole, and then I have 1 left over that gives me 1/6. All right, let's do, then what did we decide? 2 holes would look like how many 6? If I had 2 pizzas, they're both divided into 6, how many pieces are totally there? 12 pieces. So I have 12/6. Okay. What if I have 1 hole and 5 pieces? How many pieces is that total? 1 hole and 5 pieces. How many is that total, Bella? 11/6. So let's look what that looks like. We're going to do this one up here. There's 1 hole, right? 1 means 6/6 plus the 5/6 equals 11/6. Okay, so let's go. It's not about paying more attention. It's about just understanding. It's hard. I know. Okay, so now we have, and I'm kind of jumping back and forth, but that's okay. We'll keep going. 2 and 1/6 we decided was 13/6 because 2 would be 12/6 plus 1 more is 13. What do we think that, well, we can tell this is 13/6, this is 15. What do you think this should be?
14.
Probably 14/6. Now I want you to think about how many holes are you going to get with 14 pieces? And later, Ronnie, what do you think? 3. So 3 would be 6/6 plus 6/6 plus 6/6. 6 plus 6 plus 6 is what? 18. Do we have 18? No, so we couldn't get 3 whole. What would we get, Luna? 2 holes and 2 6 left over. Because remember, to get 2 holes, you would have 12/6. And then you can tell that there's 2 left over. Because we have 14. Okay, let's look at the next one. We have 15/6 and 17/6. Which one are they looking for in here?
16/6.
How many times can you get a whole out of that? 16. There's more than one. Antonio?
2.
There's 2 holes. Who can tell me how many are left over for my fraction? Antonio, go ahead.
4/6.
There's 4/6 left over for my fraction. Okay, and again, I have 16/6. I know that 12, here, let me do it this way. I'm going to do the whole thing. I'll do it up here. If I have 16/6, I know that I can do 6/6 plus 6/6. How much is that so far?
12.
12. And I need 16. So if I have 12 already, how many are left over? 4. And that's how I can do it. And then I know that this equals 1 whole and this equals 1 whole, which is 2 whole, and then the 4/6 left over. Write the mixed number as a fraction. This is how we're going to do these problems. I have 1 whole and 1/8. What is the size parts I want to work with? Angeli? 8ths. So since I want to work with 8ths, I'm going to change my 1 whole into a fraction using 8ths. Okay, and then I'm going to add the 1/8, which equals 9/8, and there I changed my mixed number to a fraction. So my answer is 9/8. Okay. Shh.
Oh, I get it.
I'm so glad. I love hearing light bulbs, but let's move on. 1 whole and 3/5. What fraction am I going to change the 1 whole to? What fraction am I going to change the whole to, class?
5/5.
5/5. And what am I going to add to it?
3/5.
3/5, and that equals
8/5. I love it.
all right, number 4. Think about what fraction we're going to change that whole to. Okay, what are we going to change it to?
3/3.
What am I going to add to it?
2/3.
And I'm going to get?
5/3.
Okay, go ahead and write it real quick. 5/3. All right, I'm going to mix it up for you a little. What if this number was 2 2/3? I can change. Remember, I can think about the 2 as 1 plus 1. So what is my first fraction going to be, class?
3/3.
Then I'm going to do plus.
3/3.
There you go. Plus.
2/3.
Now, in your head, add and find your new fraction. Don't tell me yet. Now, what's your new fraction?
8/3.
Okay, so when you get to a fraction that has a 2 or a 3 as a whole number, or a 4, remember you're just adding a whole, depending on how many there are. Okay? Now comes a little more tricky part. We're going to change the fraction to a mixed number. So in this case, you have to decide how many wholes you're going to get out of the 11. So if I pull one whole, that is 4/4, correct? If I had 11 and I took 4, how many do I have left? 7. You're quickly through subtraction. Okay, so I have 7 left. Do I have enough for another whole? Yes. So I'm going to say, now I've pulled out 8 total from 11. How many are left?
1.
3. 11 minus 8. It's 3. Four plus 4 is 8. Plus 3 more is 11. 11/4. Now I would just write this as this is 1 whole plus 1 whole plus 3/4, which is 2 3/4. Go ahead and write it. I have 6/5. How many whole can I get a whole number out of there?
Yes.
What does it look like? Yeah, it looks like 1, but what does it look like as a fraction?
5/5.
Okay. If I pull 5/5 out, how much is left over?
1/5.
So that would look like 1 whole and
Plus
1/5. This one's a little harder, I know. But it's the same idea, just thinking backwards. All right, let's look at the 13/10. Can I pull a whole out of this?
Yes.
What does the whole look like?
10.
How much is left over?
3.
And so it looks like 1 and 3/10. Okay, let's look at what this would look like if we're changing this to a mixed number. Can I get a whole? Can I get 1 whole out of this? Yes. It would look like 2 2s, or 2 halves, right? Is there more? I now have 10 left. Can I do it again?
Yes.
Plus 2 halves. Now I have 8 left. Can I do it again?
Yes.
I now have 6 left. Can I do it again? I now have 4 left. Can I do it again?
Yes.
Who's whistling? Okay. It needs to stop the extra noises. I now have 2 left. Can I do it again?
Yes. Wasted the box.
Do I have any left now?
No.
No, I have 0 left. Now I'm going to convert these to whole numbers. This is 1 plus 1 plus 1 plus 1 plus 1 plus 1. Do I have any fraction left over?
No.
Each one of these equals a whole number. Count them up real quick in your head. How many wholes is that?
6.
And that's changing it. It is not actually a mixed number, but you get the idea. You're supposed to be changing it to wholes and fractions, and there's no fraction left over, so you just change it to the wholes. Okay?